Okay. So we don't know the initial concentration. Those are zeros initially. Change, this would be minus x, plus x, plus x, x, x. And then, I don't know, question mark minus x. That's weird, but okay. So, what'd you guys use? X minus x?
Well, no, I'm just substituting it for x.
So you just, once you got your number, you put it in there? Okay. So, how do we get the H plus concentration? Bree. How do we get this number right here? Right, 10 to the negative 2, or 3.5, and you got, I don't know what I did with that number. What did you get, Bree?
3.16 times 10 to the
Negative 4?
Yeah.
Yeah. 3.16 times 10 to the negative 4. That goes in for both of these values, and it goes in here. Okay? So I'm just going to erase this and rewrite the Ka expression. So the Ka expression is x squared over question mark minus x. Okay, so it's 6.3 times 10 to the negative 5 equals 3.16 times 10 to the negative 4 squared over, we'll go x minus 3.16 times 10 to the negative 4. So if you ignore this, so you just have x down here, that will be, so I don't want to confuse you actually, because my notes, I have that. But if you ignore this, then you're just solving for here, and that is your initial. And if you do that, you get 0.0016. That's what I got. But let's not ignore it. Did anyone not ignore it? What did you get here?
I got 0.0019.
0.0019. Oh, so you didn't ignore it either. You did.
No, I didn't.
Oh, all right. So let's make this x again, just because that's weird. 6.3 times 10 to the negative 5 times x minus, what's this number times that number? What do we get? 1.9. 1.9?
Yeah.
You didn't. That's it. Killed it right there.
9.
I like 9 better. Times 10 to the negative what?
8.
8 equals, what's this number squared? 9.98.
Yeah.
10 to the negative 8. Okay, then we add this, right? So add that, 1.99 times 10 to the negative 8. And then we divide that. I don't need to go through all the math here. Then divide that. And then x, you guys say it's 0.0019?
Yep.
Yeah. I guess that makes sense.
Don't have 5
Pass it on. Jack had the answer, so it didn't work out.
Yeah, okay. So that's how we do these. So if they give you the initial and they give you the pH, you solve for Ka. If they give you the initial and the pH, you solve, I just said that, Ka. If they give you the Ka and the initial, solve for pH. Then there's only one of 3 ways they could ask these questions. So your homework, 43 through 46 are the acid ones. Okay, so we have 1 of each. Okay. The previous problem, yeah, let's use the previous problem. What would the percent ionization of the acid be? So not this problem, the one before it. I want to know what's the percent ionization of the acetic acid. So that previous problem. I want to see if you can figure it out without me telling you how to do it. What is the percent ionization? Write this down. Calculate the percent ionization of the 0.1, write this down, Dylan. 0.1 molar HC2H3O2 from the previous problem. So the vinegar question, where you had a pH 2.87, we calculated the Ka. So in that problem, what is the percent ionization of the 0.1 molar acetic acid? I haven't gone through this with you yet, but you know what percentage means, and you know what ionization means, I think. What's ionization? It means a couple different things actually. So ionization energy is the energy required to remove an electron from an atom in the gaseous state. So ionizing means taking electrons away from atoms, which is kind of what's happening here. And in this case, it's just dissociation. So if you have HA, it dissociates H plus, A minus. That's called ionization. So they're becoming ions. So ionization. So I want to know the percent ionization of that. How much of the acid dissociates? That's basically what I'm asking, but I need a percentage. Remember, I told you it should be less than 5%. Pretty sure that's not going to help her out.
Ionization.
Oh, I gotta show you this stuff. I gotta show you. After this, we'll show you this.
Well then.
We're just magnets to make it more fun.
Magnets are fun. They're more better.
They are more better. So if the red is, wait. This is better.
The red is hot. This is even more better.
Even more better. Or
More or better. The dash of big red. Also southern. Well, that's also
Liam, is this still on the thing?
Yeah. But I wasn't going out.
Can I do this?
Yep.
What the? Who's stealing my stuff?
Did you buy magnets?
A long time ago. Okay. All right. I can't get it perfect. I don't have enough magnets, but here's the concept. You should already understand this. Weak acid, so it's really bad at doing what? Dissociating, giving off H pluses. So out of these 8 molecules, only one of them dissociates, and the other 7 stay together. So forget this question for a second. Look at the magnets. What would be the percent of H pluses that dissociated? How'd you figure it out? So you started with 8 molecules, 1 dissociates, the other 7 stay together. That proves. So again, don't be confused. This isn't really a product. It's just leftover react. I'm just trying to show you that. So what would be the percent of the H pluses that dissociated from here? 1 out of 8, right? 1 over 8 times 100. So what's that? 12%, right? That's still way too high. I don't have enough magnets. It should be less than 5%. So, stay with me. Everyone here understood to do 1 divided by 8 because only 1 dissociated out of 8. Correct? Okay. Relate that to this, where you actually know molarities. So I'm using number of molecules. This, you know the molarity. So you know you start with 0.1. Well, of the 0.1, how much dissociated? What is the molarity of your H plus? Then it's just part over whole times 100, just like you did.
Oh man.
Same exact concept, except they give you the numbers.
Oh, all right, there we go. I got that.
Same exact concept.
How much of this associate is only 0.0013 molarity out of the whole total 0.1?
Right. Very good, Justin.
So you got 0.6. And multiply that.
76%, Earl? Yep, good. I'm glad you realized it's wrong.
It's the concentration of H+.
What did you?
How much?
How'd you get that number?
How much of those 3? No. I think you're looking at the. This is from the acetic acid So we skipped, we got 1.3%.
Yeah, I wanted to go back to the acetic acid. We could have done the benzoic one. We could have done that.
Yeah, that's why I was confused. It's on off. It's on off with stay put.
I'm working both days.
Okay, look up here. We started with 0.1 molarity. I'm going to skip the whole ice table stuff. What did we end up with? 0.0013, right? And same as this, 0.0013, but no one cares about that. So only 0.0013 moles in 1 liter dissociated out of 0.1. So you do 0.0013 divided by 0.1 times 100, and that's 1.35% is what I got. Because isn't that 0.00135 technically? Isn't that what we had? I had the 5. So it's 1.3%. 1.3%, I had a 5 next to that 3. So I don't really teach it except for that because you understand the concept, you know what percent means. So percent ionization just means how much of the acid dissociated, that's it. That's like one of those like part F questions that they just tack on at the end, what is the percent ionization? So, okay. Let me show you this stuff here, then we'll do a base example to help you with the homework, and then that'll be it. All right, so lights please. Basically, that's it. Can you get those two? Just the first. Earl can help you if you want. Oh, this is still recording for no reason.